Hey guys, today we're going to look at multiplying radical expressions. And in multiplying your radical expressions, it's the same as multiplying other expressions. You're going to use the distributive property, or some of y'all may look at using FOIL method whenever you have two binomials, and then you're going to combine like terms. And for instance, example number one, let's just recall what we've done with just our basic expressions. If you were to multiply this, you would distribute that 2x to what's inside of the parentheses, and where you can, you would combine like terms. That is what you're going to do with these. So let's take a look. Examples. We're going to multiply and simplify. So radical 3 times radical 3 minus radical 2. I'm going to distribute that radical 3 that's outside of the parentheses. Bring it through. Whenever they are the same, if this is the square root of 3 times the square root of 3, your answer is going to be 3. Whatever's under the radicand is going to be your answer. But whenever they're not the same, you may have to simplify after you multiply together. Okay, so because be able to see this, what this turns into, a radical 3 times radical 3, radical 3 times radical 3 equals a radical 9. Square root of 9 is 3. More or less saying radical 3 squared. So that equals 3. Square root of 3 times square root of 2. Square root of 3 times square root of 2 equals square root of 6. And that's as simplistic as I can make that. 3 minus the square root of 6. If you would like, pause the video and see if you can work this one. See if we get the same answer. Alright, so I have the square root of 3 times the square root of x. Well, that's going to be x square root of 3 minus, and then I'll write this one out. I have the square root of 3x times 4 radical 3. And I'll rewrite it because they can all go under. Remember our product rule for radicals. I can turn around and I know that this is 3 times 3 times 4. Whoops, 4 is out here. Rushing through. Times x. Well, I can pull a 3 out. Square root of 9. So I have x square root of 3 minus 4 times 3 square root of x. So this ends up being x square root of 3 minus 12 square root of x. And it doesn't matter if you can see this and you work it in 2 steps and you get the same answer, or if you have to write everything out and it takes you multiple steps to be able to solve it. You need to work how your brain pictures the problem. Think it through, write everything out. If you feel the least bit confused, then write it out. Talk to yourself while you're doing it. Okay. Another example. This time, those were just dealing with the distributive property. This time we're going to multiply two binomials together. And we've done that to where in our problems, we have something like this, and some of y'all may like to use the FOIL method and others just view it as distributing. But we're going to do the same thing. First, outer, inner, last, or just distribute each term as you go through. So here's an example that I've worked. I have these two radical binomials. I can't simplify anything in either one of them. Similar root indices, but my radicands are all different and they're in simplest form. X is simply x and these are all prime numbers. So I distributed my x times the radical 3 or square root of 3 and the square root of x times the square root of 5. And I make sure that I include that negative sign with that radical 5. And that's the first portion right here. And then I distribute my square root of 2 to each of these terms. So 2 times the square root of 3, or square root of 2 times the square root of 3, plus the square root of 2 times a negative square root of 5. And then I combine. This becomes the square root of 3x minus the square root of 5x plus square root of 6 minus square root of 10. And that's in its simplest form. So if you would like, pause the video and work this problem. Alright, square root of 5 times the square root of 5 is simply 5. And then plus 7 square root of 5 minus 7 square root of 5 minus 49. Notice my middle terms. They cancel. What am I left with? 5 minus 49. And I have a negative 44. This right here is a very important part. We'll go ahead and talk about it. These two are conjugates. They have the same numeric values in both of them, but the signs separating them are different. Whenever you have that, you will end up canceling out the middle term. Whenever you have that, you'll end up canceling out the middle term, and we'll use those more as we move along. Alright, some more example problems. So pause the video, and then we're going to work through them and see if we end up getting the same answers. Hopefully so. Alright, I'm going to distribute the term outside of the parentheses. And then simplifying. Remember, this is 4 times 5. 4 is a perfect square, so I'll pull out a 2 and leaves a radical 5 underneath there. I can view this as 25 times 2. I can pull out a 5 and that leaves a radical 2 under there. And those can cause some consternation because the numbers are just opposite inside of each other. Take your time, think about what you're doing, and make sure, yes, I am correct. They'll have questions like that cause you to think, well, what did I do wrong? Again, I'm going to distribute. So I end up with a radical 18 plus a radical 12. 18 can be rewritten as 9 times 2, and 12 can be rewritten as 4 times 3. Again, I'm picking a perfect square that is a factor. That way I know I can pull that out. 3 radical 2 plus 2 radical 3. Again, the distributive property, that's a 5b. I know my handwriting is not the best. So to help us visualize, 5b times b plus 25b. That turns into 2b radical 5 plus 5b. Now I'm multiplying binomial terms. So square root of 3 times square root of 3 is 3. Square root of 3 times a negative 6 is a negative 6 square root of 3. 6 times the square root of 3 is 6 square roots of 3. And 6 times a negative 6 is a negative 36. My middle terms cancel. 3 minus 36 is a negative 33. Five square root of 3 times square root of 3 is 15. 5 times 3. I'll write it like that. Minus 5 radical 3, because 5 radical 3 times a negative 1. Negative 5 square roots of 3 plus 2 square root of 3 minus 2. So it is 15 minus 3 radical 3, negative 5 plus 2 minus 2. 13 minus 3 radical 3. And that is multiplying radical expressions. Please keep in mind, math is very foundational, and you reuse what you've already learned, except in a slightly different context. And the actual processes that we're using for this are what we use with our expressions and just our variables. So there's just a little change to it in dealing with the radicals. So please critically think, structure your homework, write everything out, and good luck on your homework problems dealing with multiplying radical expressions.